Alright, so we've got this Squier guitar neck here. It's got a rosewood fingerboard on it. And the idea is to get this play ready to be installed on a made in Mexico body. This is a made in Korea Squier neck. Now there's a couple issues with it. The first and most important is that the thickness of the neck here, the neck and the fingerboard, is actually about 1.07 inches. So it's a little tall for most guitars, meaning the saddles will have to be adjusted quite a ways up. And so we're going to remove 7/100ths of an inch from the bottom here. I'll talk about that in a second. Also got a couple of fret ends popped up. Fret number 14 on the treble side is popped up, and number 1 on the bass side. The nut is also shifted that way a little bit. I don't know if that was done on purpose. It looks like it's been re-glued since it's been shifted, so I'm not sure if that was on purpose to relocate the treble strings in this way more on the fingerboard, or if it was just re-glued without much care and it was accidental. I'm not really sure about that. Alright, so what we've done so far is I've taken a really light sanding on the back of this heel here because it did have some divots and it picked up a little bit of finish from the previous neck pockets, so this isn't a completely flat surface. The sanding on a known flat surface, a relatively flat surface here with some really fine 320 sandpaper, has shown that this is a generally flat plane here. However, there is some rounding. You can see where we've got dullness here all in this area, but a little bit of shine remaining along this edge and over here. So this area is generally in plane, however this edge and this edge are likely not. Also, one of the complicating factors is that the end, and you can kind of tell obviously on the right hand side especially, this is not square. It appears that the angle between the edge right here is slightly greater than 90 degrees on both sides of the neck. Now, whether that was done for fitting purposes or for some other reason, that's going to make it difficult because the only face that I can reference to make this cut, to shave this down, is going to be this actual face. What I'm going to do is glue a reference block on this face that has two parallel sides and a 90-degree face on the bottom, and use that as a reference to run through the table saw against the fence. Alright, so I've got our piece of wood clamped on here, a couple of clamps. Try to be really careful with the clamps, making sure that they only put pressure on the portion of the neck and the heel that I knew was flat. So this is my flat top ripping blade. It's got a really thick plate on it, and it's a full 1/8 of an inch, so full kerf. So this thing is going to be about as vibration free as you can get with a blade, which means it's going to produce a really nice, clean, flat, smooth cut. I've got this already set up so the outside of the tooth here is going to line up with my scribe line on the heel of the guitar neck. So now you can see when I have this reference piece, I can see how the very edge of the tooth is lining right up with that score line, and that should give us a nice clean flat cut. I double checked the squareness of the fence, the squareness of the blade, the squareness of the table. We should be pretty good. This is going to be about the most accurate way to do this maneuver, I think. So we'll try it out and see how it works. Yeah, 0.97, 0.98. So overshot a little bit, but it should be okay. just breaking these sharp edges here with a little bit of sandpaper. What I've done is I've found a drill bit that is the right size to clean up these holes in the back. It is 0.13 inches, so we got about 9/64 size. And I've just attached to this tapping thing. And that's going to allow me to really carefully clean these out, and I can tell it's just about exactly the right size because as I clean these out I can still see the threads in the hole from the screws that were in here before. So this is a good size. Doing it by hand allows me to kind of follow because these holes are not perfectly straight. It'll clean them out enough, and then I'll need to get some maple plugs that are about this size. Alright, so I've made a dowel that is the exact same size as the holes that I kind of reamed out here. So use that by drilling a hole through a piece of steel, cutting a piece of maple, nice piece of straight maple, and chucking the piece of maple in the drill and then putting it through the hole in the steel. It doesn't work for a really long time, but I think I've got enough material here to fill all 4 of these holes. So now I'm going to put some glue in here and fill these holes up with this piece of maple. And this glue here, it's got water in it, obviously. So what's going to happen is that as I apply the glue, I have to work relatively quickly because it is a pretty close fit. And the glue is going to cause this plug to swell. And if I don't get it in there quick, enough glue, I do want to get this thing to sort of push glue out of the bottom. We want glue contact all the way down. There we go. So that we've got a nice bond on all sides of the hole. That's important because we are going to be drilling new holes in here, and we don't want the drill bit to deflect when we're drilling, and we want the new screws that are going to connect this neck, which could be very close to the current locations. We want to make sure that there's a good enough amount of wood there, even if the new screws sort of go right in the edge of one of these holes.